Okay, today we're going to be looking at dealing with Pythagorean Theorem word problems. So, with these, you got to read the questions carefully. It helps to draw a picture with it, and then go through and do our work. So our first problem says that Alan wants to decorate his rectangular pool for his party by stringing lanterns diagonally across it. The pool is 21 feet wide and 28 feet long. How long will the string of lanterns need to be? So the first thing we want to do is go through and draw ourselves a rectangle. We're going to make a rectangle to represent our pool. Pool. It's a nice, pretty swimming pool. And we go through and say the next part of information that we are given is it's 21 feet wide and 28 feet long. So we need to go through and label that. So 21 feet wide, 28 feet long. We're going to be taking and making a diagonal strings going across like this. So here we have a nice right triangle. Since I have my right triangle, this is my A, my B, and I'm going to be looking for C. So we're going to use our Pythagorean theorem. A squared plus B squared is equal to C squared. So I'm going to do 21 squared plus 28 squared, and that will give me my diagonal squared. 21 squared is 441 plus 28 squared. This one is 784, and that's equal to my C squared. I now add each of these together, so that gives me a 5, that gives me a 2, and that gives me a 1, 2, and that's equal to my C squared. I now have to take the square root of each of these, so the square root of C squared and the square root of 1225. So this now tells me that C is 35. So each string of lights has to be 35 feet per string, or I need 70 feet total to be able to put lanterns above my pool, and hopefully they don't fall in and electrocute all of us. Okay. Moving on to our next example here, we have the bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder reach on the wall? So first thing I want to do is draw my wall here. Here's my building. Here's the ground. I've got a ladder. My ladder's leaning along here. And we know the distance from here to here is 3 feet. They tell me that my ladder is 12 feet long. And what I'm looking for this time is how far is my ladder reaching up on the wall? Well, this time I have my C, but I'm missing the B, because here's A, B, and C. So I'm going to use my Pythagorean theorem again. A squared plus B squared is equal to C squared. A, that's going to be 3, so 3 to the second power, plus, well, I don't have that one, that's my X, is equal to 12 to the second power. Well, 3 squared is 9, plus my X squared, and 12 squared is 144. I take and subtract 9. I now have X squared is equal to 135. Now I'll take the square root of X squared and the square root of 135. So if we had to go through and simplify our radical for this one, the square root of 135 That's equal to the square root of 9 times 15, which would be 3 square root of 15. Or if we just punched it in our calculator, we would say that it is approximately 11.6 feet up on our wall. Looking now at example number 3. Example number 3 says a baseball diamond is a square with an area of 8,100 feet squared. What is the distance from home plate to second base? Well, first thing I need to do is draw myself a pretty little picture. My picture here, oh, that's a baseball diamond. Here is my home plate right here. Here I have my bases. First, second, third, I got home plate here. Who's on first? I don't know. No, he's on third. Okay, so they tell me that the area of this is 8,100 feet squared. So I need to know what's the distance of each of these sides here. Since it is a square, I can take the square root of this 8,100 to find each of my edges, because the area formula of a square is side to the second power. So if I take and do the square root of 8,100, that will tell me my side, or my x, which tells me that each of these things are 90. Now that I have that information, I can use that to help me figure out how far is it from second base to home plate, straight across. This is my right triangle here. Since I have my right triangle, I'm looking for my C, given A and B. So again, I'm going to use A squared plus B squared is equal to C squared. So looking at this right here, I'm going to do 90 squared plus 90 squared is equal to C squared. I already know that 90 squared is 8,100 because that's how I found my 90 in the first place. So I have 8,100 plus 8,100 is equal to C squared. So that gives me some zeros, a 2, and 16,200 is equal to C squared. Take the square root of both sides. So I now know that C is equal to 90 times the square root of 2. If I take and punch that into my little handy-dandy calculator, I can find the distance from home plate to second base is approximately. So we now know that the distance between these two is 100. It's approximately 127.3 feet. Using applications of our Pythagorean Theorem. You need to always pay attention to what you're doing, read each problem carefully, and as always, take your time, and good luck.